Hello guys, in this video I'm gonna go over a few examples of integrals and we're gonna solve some trigonometric integrals, and they are indefinite, like there is no limit on them. So let's start with that. So basic rule is we want to try to make it as simple as possible so that we can integrate it, and we can use some trigonometric identities to make them simple. So let's do it. Okay, so first one we got is 1 over 1 minus sine x dx. So what we can do, if we can multiply it by the conjugate, so 1 over 1 minus sine x, what we're gonna do, we're gonna multiply it by the conjugate of this one. The denominator is going to be 1 plus sine x, and if we are multiplying, we're gonna divide it by the same 2. Okay, so what will happen here, when we do that, basically these two cancel out, gives us 1, so does not change our original integral. Okay, so what will happen here, so 1 multiplied by 1 plus sine x gives me 1 plus sine x, and the denominator 1 minus sine x multiplied by 1 plus sine x is basically, if you remember, a minus b multiplied by a plus b. This is basically equal to a square minus b square. So we're going to use the same formula over here. So a minus b, a plus b is equal to a square minus b square. So that gives me 1 square is 1 minus sine square, so that gives me sine square x dx. Okay, let me erase this so you can write those formulas and remember them, and you can use them in your integrations. Okay, so let's finish this. So 1 plus sine x over 1 minus sine x. So remember the trigonometric identity, sine square x plus cos square x is equal to 1. Okay, and if we subtract sine square x from both sides, see, so that will give me 1 minus sine square x is equal to cos square x. So we can change this 1 minus sine square x to cos square x. So 1 plus sine x divided by cos square x dx. Yeah, let me erase this again. So remember the trigonometric identity. You can make a flashcard of those. So this is like a flashcard trick. Okay. All right. So, and now over here, so this part we're gonna break it down. So 1 over cos square x is basically what, 1 over cos is secant. So 1 over cos square x is secant square x dx, and I'm breaking it down, plus sine x over cos square x. So sine x over cos x gives me tangent x, and 1 over cos x gives me secant x. So this is basically equal to secant x and tangent tan x dx. Again, I'm gonna do it over here. I'm running out of space here. So 1 plus sine x over cos square. Okay, so I'm gonna break it down. That gives me 1 over cos square x plus sine x over cos square x. Okay, so 1 over cos square x, we wrote it secant square x. Okay, and so this becomes secant square x, and this becomes plus, so I'm gonna break down this cos square x into 2 cos x, so that gives me sine x over cos x into 1 over cos x. See, sine x over cos x gives me this tangent x, and 1 over cos x gives me this secant x. All right, so I think you guys can do it by yourself. Let me erase it using my eraser. Okay, so, and we know that integration from the formulas, the integration of secant square x is tangent x, and the integration of secant x tangent x is just secant x plus the constant of integration. All right, let's work on the second one. So second one, similar to this one, just there is a cos written over here. So in this case, we're going to use another trigonometric identity. We can do this, but it will not work out the conjugate multiplication and division. So what we're going to do, we're going to write that trigonometric identity of 1 minus cos x, which is equal to 1 minus cos x is equal to 2 sine square x over 2. Okay, and if it is 1 plus cos x, that is equal to 2 cos square x over 2. So you need to remember the trigonometric identities, then you'll be able to solve them. Okay, so 1 minus, I'm going to write it down over here, 1 minus cos x is equal to 2 sine square x over 2. Okay, so you can use that identity, and I'm gonna take 1 over 2 out, the constant. So inside I left with 1 over sine square x over 2. Okay. And I know 1 over sine square x, 1 over sine is equal to cosecant x. So 1 over sine square x will be cosecant square x. And if it's x by 2, then it will be x by 2. So that will be cosecant square x over 2. All right, and we know the integration of cosecant square is from the formulas negative cotangent x over 2, and x over 2 gives me 1/2 on the bottom, and you all know this. Sorry, and you all know why we got 1 over 2. So because we're going to write the derivative of this over here, plus c. So this gives me, so 1/2 cancel out with this 1/2, so we're left with negative cotangent x over 2 plus the constant. Okay, so that's how we can find the integration of this term. Let's do a couple of more. I got few more. So this is cos 2x over sine square x and cos square x. So here again we're going to use another trigonometric identity. So I'm going to write it down over here. Cos 2x is equal to cosine square x minus sine square x. Need to remember the trigonometric identity. A lot of integration involved these identities. Okay, so that means this cos 2x becomes cos square x minus sine square x over sine square x into cosine square x dx. And let's simplify it. So I'm gonna break it down. This gives me cosine square x over sine square x into cosine square x minus sine square x over sine square x and cosine square x. I'm gonna put it in parentheses dx. Okay, and now you can cancel out cosine with the cosine and sine with the sine. So that will give me 1 over sine square x, 1 over sine square x dx minus integration of 1 over cosine square x dx. Okay, and we all know 1 over sine is cosecant, and if there's a square it will be cosecant square x dx minus, and 1 over cosine is secant, so 1 over cosine square x will be secant square x dx. And the integration of cosecant square x from our integration formulas is negative cotangent x, and the integration of secant square x is tangent x plus the constant. All right, again, try to remember these trigonometric identities because that'll help you a lot when you're solving the integration to make your integration simpler form. Okay, let's do one more. I got square root of 1 minus sine 2x dx. Okay, so what we can do, okay, so I'm gonna use two different identities over here. So one of them we're gonna use sine square x plus sine square x. What did I do? Okay, 1 plus sine square x, sorry, sine square x plus cosine square x is equal to 1. The other one we're gonna use sine 2x is equal to 2 sine x cosine x. Okay, let's do it. So we got integration. So instead of 1, I'm going to change this 1 to sine square x plus cosine square x. So that gives me sine square x plus cosine square x. Okay, and sine 2x will change to negative 2, this part over here, to sine x and cosine x. All right, so what that looks like, if you remember one more formula, let's say a minus b square, which is equal to a square minus 2ab plus b square, or can be written as a square plus b square minus 2ab, right? So now look at this, a square plus b square minus 2 into a and b. If I say this is a and this is b, right? So this is equal to a minus b square. So that gives me, inside the integration, we'll get sine x minus cosine x square, right? So like this formula, and this, sorry, dx, and this square root will cancel the square, right? So we're left with integration of sine x minus cosine x dx. It can be written as integration of sine x dx minus integration of cosine x dx. And from the formulas, we all know the integration of sine x is negative of cosine x sorry, no dx. We are done with that. So negative cosine x, and the integration of cosine x is sine x plus the constant. All right, so the goal here is to make our integral simpler form so that we can find the integration, and to do that we need to use some trigonometric identities. So please try to remember the trigonometric identities, because those will help you to solve a lot of integrations. Okay, thanks for watching the video, guys. Please share with your friends and subscribe to the channel. I'll be making more videos on integrations too. Thank you. Have a good day.